Okay, in this video we're going to find the integral of arcsine of x, or inverse sine, depending on how you like to say it. So there's two things you really need to know before you can do this, and they are integration by parts. And integration by parts, you might recall, is the integral of u dv, which is uv minus the integral of v du, so I kind of have it color-coded there for you. And then the other thing that you really need to know is you really need to know u-substitution, but if you don't know that, you probably haven't gotten to the point where you're trying to integrate arcsine. So I'm going to assume that you're pretty good at that, but I'll go through and do it anyway. So let's just do it. So we have the integral of sine inverse of x dx. So we need to pick a u and we need to pick a dv, and this is one of those cases where it's not immediately obvious what to do, but since you can kind of only pick a u, I'm going to let u equal arcsine of x because I can definitely take the derivative of that. And then dv has to be whatever's left over, so it's just going to be dx. So we're doing integration by parts, so I need u is going to be arcsine. I guess I should have listed, you need to know the derivative of arcsine to be able to do this, but I'll assume you know that, or you're going to find out in a second anyway. And then dv we said is whatever's left after you pick u. So when I'm trying to decide what to do, I look at the thing I'm going to integrate and I try to pick u and I think, can I take the derivative of that? You can almost take the derivative of pretty much anything, right? So really the question is, if I pick dv, can I integrate it? That's really a harder thing. And if I make dv dx, I can actually integrate it. If I try to make dv arcsine, then I'm back to the original problem and I didn't know how to do it to begin with, so that wouldn't work in this case. So now I need to find du and I need to find v. So du, 1 over the square root of 1 minus x squared, and then dx, I tend to forget to write that dx there, then people yell at me. And then v, I have to integrate dx, to find v, I have to just integrate dx, which just takes me back to x. Okay, and then I remember integration by parts is going to be uv, so this equals u, which is arcsine, times v, which is x, and then minus the integral of v and then du. So the way that I always set it up, v and du end up next to each other in kind of a table format, so I just multiply across the bottom there. So it's going to be v and then du, and that's where the dx, that's usually when I remember that I forgot to write dx, and I go back and fix my work. And so now I need to integrate this thing. So this is where it's a pretty standard u-substitution problem. So it's u-substitution, I'm going to let u equal the thing inside the radical, which is a very common thing to let u equal. So I'll find du, which is negative 2x dx, and then what I like to not mix my u's and du's and x's and things like that. So what I'm going to do is I'm going to divide both sides by negative 2, because if you look at the original, we have an x and a dx, so I can substitute for x dx in one shot, and what I'm going to substitute for that is negative 1/2 du. So negative 1/2 du is x dx. So now I have enough to substitute everything in, so I'm going to rewrite this part because I'd rather have the x kind of lead. So minus the integral of, alright, so it's, at this point, u is 1 minus x squared, so I really have u to the negative 1/2 because it's in the denominator, and then x dx is being replaced by negative 1/2 du, and so this I can integrate without a problem, I think. So first thing I'm going to do is I'm going to pull out the negative 1/2 that's in there, so I'll get plus 1/2. And then it's u to the negative 1/2, so add 1 and then times the reciprocal. So add 1 gives you 1/2 for the exponent times the reciprocal, which is 2, so it's going to be 2u to the 1/2. And then don't forget your plus c. And then the original problem didn't have a u in it, so I need to substitute back in for that. So it's going to be x sine inverse of x plus the 2 and the 1/2 cancel, and I just get radical 1 minus x squared, and then plus c. So that's how you find the antiderivative of arcsine. I hope you found this helpful, and good luck.